There are lots of ways in which closures are useful in JavaScript. In this framework aside, let's talk for a moment about how we can use closures to our advantage for making patterns that would be otherwise impossible. In this case, let's look at function factories. We've already seen how we can use some of the language features of JavaScript to allow a function to be called under different circumstances with different default parameters. We did that in our function overloading lesson. But here, we're going to show how we can do even more powerful and flexible patterns using the fact that closures exist in JavaScript. So instead of creating a greet function, I'm going to create a factory. A factory just means a function that returns or makes other things for me. So this make greeting is going to return a function. And I'm going to accept a parameter, language. And then I'm going to return a function. I'll actually return, I could name it greet if I want, it doesn't really matter, but I'll just return a function that'll be like our greet function that we've been using. And let me just copy and paste in what I typed before. So this function that's returned is the same logic we had before. If the language is English, then it'll console.log hello, and then my first name, last name that I pass into it. And if language is Spanish, this is for Español, then it's console.log hola, then first name, then last name. But the difference is that instead of passing language to this function, I'm passing it to the outer function and then returning that inner function. So the language will be trapped or collected in the closure. That is, when I try to reference it here, when I execute this function object, it will look up the scope chain, and even though makeGreeting will have been done executing and its execution context is gone, I'll still have access to language. That lets me do something neat like this. I can say, let's call it greet English, and I can execute makeGreeting and pass it a language. And then I could do greet Spanish and execute makeGreeting and pass it a different language. Now, what will I have at this point? Stop and think about it. What will be inside of greet English, and what will greet Spanish point to? Well, makeGreeting executes. English is the language in the first case, and it will return a function. That function's outer reference will point to what the language was when makeGreeting was executed here. Then it ends. And so the function that was returned will still point to the language variable en, because I executed makeGreeting and it was its own execution context. Then in the second case, I execute makeGreeting again, so it gets its own execution context, where language will be es, so a different spot in memory. And the function that's returned from there, it will point at that execution context spot in memory. See that? So even though these two functions lexically sit inside the same makeGreeting, they're going to point at two different spots in memory because they were created during two different execution contexts. Imagine that in your head. Think about it. One execution context here, another execution context here. And so if I had executed the function at this point, if I had executed this inner one, it would have pointed to en, English. And if I had executed the inner function in this case, it would have pointed to a memory space that said es. And those are wrapped up. Those are closed up. I have a closure inside the result of this and a closure inside the result of that. So greet English is a function object whose closure points to language being English. And greet Spanish is a function object whose closure points to a different execution context for the same function, where language is ES, Spanish. It's important to remember that even though it's the same function, every time I execute it, it creates a new execution context with new memory space, no matter how many times I call it. All right, so now that I've done that, I can call greet English, and it expects first name and last name. So I could say John and Doe. And I can call greet Spanish, this function that was returned. It expects a first name and a last name. I'll say John Doe. And now I'm executing them. And it will execute, look for language in the scope chain. In the first case, it will find EN. And in the second case, it's going to find ES in the scope chain. So when I run this, I get hello John Doe and hola John Doe. So my make greeting function has acted as a factory function. And I'm taking advantage of closures to essentially set the parameter value that's then used inside the function that's returned. So I've created a function that is using this value always. It always has access to that initial parameter, and I could have other parameters in here. And yet at the same time, my greet English, I can't really directly access that value anymore. This is hidden from my being able to use it down here in the global context, but the function itself, when it runs, has access to it. All right, if you're confused a little, that's okay, but let's walk it through either way. Here's all my code for this function factory. So when it starts, I have my global execution context, which has the greet English, greet Spanish variables, and the make greeting function. When I hit this line, it calls or executes make greeting. And so that gets its own execution context. And I pass language. So in that execution context variable environment, language is EN for English. Then it returns a function, which is stored in greet English. It's pointing to that function. And make greeting, that time, ends. And that memory space for that execution context is still hanging around. Then on my second line, I call make greeting again. And this is the important distinction. In the previous example we looked at, when we filled an array with functions, we only called that outer function once. So all those functions inside that array pointed to the same memory space. But in this case, we're calling the function twice. When I call the second time, I get a new execution context. Every time you call a function, you get a new execution context. It doesn't matter how many times you call it. And so that new execution context has its own variable environment. And the language is Spanish in this case. And then that returns a function object and finishes. So now I have two spots in memory that are hanging out with those two separate execution contexts once contained. Then when I get to the greet English, where I'm actually calling the function that was returned, that creates a new execution context with first name John and last name Doe. But the outer environment reference, well, we know it needs to point to one of the execution contexts created by make greeting, because that's where it sits lexically. And the JavaScript engine knows that this first one was created during that first execution context, so it points to that one, the one it was created inside of, the execution context that returned it. And so that's where my closure is. So greet English gives me my English greeting. When I hit the second line, greet Spanish, that's pointing at a very similar function object And so that generates its own execution context. But that function object was created in the second call to make greeting. So its outer reference points to that second execution context that was created for that second call. And so it has its own closure. It forms its own closure. So when greet Spanish executes, it sees that language was ES, and I get my Spanish greeting. Make sense? Again, the key is realizing that every time you call a function, it gets its own execution context, and any functions created inside of it will point to that execution context. This is doing exactly what it should. It's pointing to the memory space as if those other execution contexts hadn't disappeared. It knows which ones to point to properly, where these inner functions were created, and when. This is, again, a language feature. And pretty cool. So take a good look at this code. Try it out for yourself. Think about it. You'll see that this is extremely useful because we can have a core set of logic, but then make ourselves functions that are then easier to use. I don't have to always pass the same parameters. I could just create some new functions that have some parameters by default by using closures. So again, take a good look at this. Remember that this is returning a function that has access to what this variable was at the time that it was created by pointing to that memory space. And that lets me create functions from other functions. And that's one of those things that you can do in JavaScript because functions are objects. All right, so we've seen some great examples of first-class functions and closures in JavaScript. Let's move on.